Okay, okay.
Yeah, YouTube also there. Yeah, sir, it is live streamed on YouTube also.
Yes, sir. Yes.
Imtiaz sir, can you share the link there? If anyone joins, I think no, this
Share in chat, sir. Just
yeah,
share.
it may exceed 300 people here, hopefully. And at that time, no, there should be a provision to attend from YouTube also. Yeah, thank you. It is there. Thank you, Mohammed sir. Sir, shall we start? Sir, with your permission, shall I start? Ramesh sir.
Yeah, yes, sir.
Oh. Yeah. So good afternoon, all of you. It's my pleasure to welcome all of you for this IQAC webinar on green and energy audit and its importance in energy management. A very, very important topic, and a topic it will continue throughout our life. As long as human being stays on the earth, this topic is going to stay forever. That is the importance of this topic. It is not contemporary or like that. It is continuous since from the ages, starting from the existence of human being into earth until today. This is the most important topic to be discussed and given more attention. Okay. And as we know, growing concerns on environmental pollution, carbon mitigation, and stringent norms have forced industries, residential sectors, public places, and schools and colleges to have active energy management policy. The purpose of human stay is energy conversion and utilization. Ultimately, what human does in his stay in his on the earth, he just converts energy from one form to another one. This is the broad meaning of the life, we can say. It results, ultimately it results in carbon emission. The carbon footprint from various commodities is to be minimized. That is the most important thing, to reduce the pollution as well as to gain the carbon credit. Sir will elaborate more on this carbon credit gain and its importance as far as industry operation is concerned. He will elaborate more on this. There are two aspects of energy, energy. The one is the generation. The generation is very, very important, where disorderly energy is converted into orderly energy. You can call a mechanical thermal energy or chemical energy is converted into electrical energy. Electrical energy is orderly energy. And this is dictated by Carnot efficiency. It sets the highest limit of efficiency for a power generating cycle. And as we are aware that Carnot efficiency cannot be attained. It's a theoretical efficiency. And it is known that 60% of the input energy goes as the waste, and this enters the environment as waste stream, and it pollutes the environment. This is one part. And after this, once energy is generated, it has to be transmitted to the utilities. Utilities includes different industry sector, residential sector, market, shopping complex, and so many. And once it reaches the utility, then judicious use of this energy is very, very important. And here comes the role of energy manager, energy auditor. He has to plan in the best possible means of utilizing energy. Energy utilization should be properly planned, and it is the duty of energy manager who will plan for a particular community, for particular industry, how energy utilization can be carried out. It's a very, very important activity, starting from our home, workplace, market, on road, and everywhere. Today's webinar by IQAC is planned to create awareness about this important topic amongst the stakeholders, faculties, and students. We are privileged to have eminent energy manager, auditor, Mr. Ramesh Dharmaraj. He is senior fellow at Industry Efficiency Group, TERI. More than that, he is the proud alumni of our main campus. We welcome you, sir, for today's webinar. We are privileged to have your presence as a guest speaker for today's webinar. And I also would like to welcome all the deans of various schools and chairmen of different departments. More than that, the students, they are the important people, important stakeholders as far as this energy management activity is concerned. Before I request Dr. Dharmaraj to present his presentation, I will take his permission to introduce him to the participants. Ramesh Dharmaraj is a senior fellow. Mr. Ramesh Dharmaraj is a senior fellow in Industry Efficiency Group, TERI. He is having 28 years of vast experience in the field of energy auditing and management. And he has completed his MBA in energy management from Annamalai University in the year 2013. He has completed Masters in Business Administration Marketing through IGNO, and he is having bachelor's degree in electronics engineering from Dayanand Sagar College of Engineering. He's having certifications he's a certified energy management system or EMS system auditor, ISO 50001 series. He's accredited energy auditor by Bureau of Energy Efficiency, BEE, a very important body as far as energy directives and guidelines are concerned, as far as India is, Indian government, and certified energy auditor by Bureau of Energy Efficiency, Minister of Power. And he has undergone relevant training in energy efficiency and is trained in safety housekeeping and in different countries. He also underwent a training on lighting systems. Countries, he has visited number of countries on his professional as his professional career. He has visited Afghanistan, Ethiopia, Ghana, Kenya, and Nigeria, and so many USA, Uzbekistan on energy management assignments. His employment record is still from 2007. He is associated with the TERI, the Energy and Resource Institute, Bangalore, as a senior fellow, energy auditor, industrial efficiency group. And from 2004 to 2007, he was associated with energy efficiency and renewable expert for a German organization. From May 2004 to 2000 to 2004, he was with the Solar Systems Bank, ME's Solar System Bangalore. And November 1992 to 2000, he was with the Foresight Power System Bangalore. He's having very vast experience in energy sector, energy auditing. He has completed more than 1,000 energy audits. You can imagine his vast experience, his expertise in this particular area. We are privileged to have you as a guest speaker for today's webinar, sir. We are really privileged and honored by your presence. Now I request Mr. Ramesh Dharmaraj to continue with his presentation. Please, sir.
Thank you, sir. The energy audit is a bit vast subject. It's a multidisciplinary. Anyway, today will be a bit of introduction only. If the college permits, so we can take frequent classes. That is not an issue with TERI. The contents of today's presentation will be energy demand and the background to initially understand why we require energy management or energy audit. And I introduce a new subject called PAT, the Perform, Achieve, Trade, which will be more important as far the university is concerned. And later I'll introduction of a few slides from the TERI. This is the latest scenario of our Indian electricity generation. Living the present year due to pandemic, the generation is down by 11%, and even our GDP is also down by 10%. Rest of the year, you can see the trend of the growth of the power generation, both the renewable and the conventional. As you can see, India started green energy conservation from 2015 and 16. The vast difference. Earlier one is all lower consumption generation capacity. Now we can see it is increasing by quite large. And this is the fuel generation from the fuel. You see the maximum generation is from the coal. And from last 5 years, we added around 80,000 megawatts. And gas, because of the shortage of the gas, we had to import it, and our Godavari basin was a failure. Therefore, the gas is stagnated, and diesel is come down. Even you can see our Yelahanka diesel plant was removed. Now we are coming up with a gas-based power plant, and nuclear, it's a central government control and slowly coming up. Hydro also not much change over years. Wind is increased, and next is the major increase is you can see in the solar, which is solar when you compare to our target of the government of 175 gigahertz by 2022, still we are way behind, below the target as on by 2020 also. And biomass is also slightly increased. And this one gives, because as you know, the solar and most of the projects are based on the time of the daytime only you can generate it. The wind also is during the monsoon. Therefore, the 24/7 generation is always with the coal. Therefore, it is contributing almost 74%, which accounts to the carbon emission, and that is the main this one. And next comes is hydro around 9%, and natural gas around 5%. Natural gas are normally they run with the peak power stations, and wind is seasonally, and biofuels. Nuclear is once again a 24/7, and the solar is at present only contributing by 2017 was only 2%. Now it's almost increased to 5%. Therefore, coal accounts to 3/4 quarter of the Indian electricity generation at present. And this is the important slide. When you look at it, the production in India and the import. Import is a oil fuel, almost a natural gas, and types of the fuels. This is this one, and type of the fuel consumed. And you can see this is a gap, huge gap, the transformation losses, which we concentrate on the energy efficiency and the audit to improve on that. And this is a sector wise, which is the consumption more. You can see the industry is the number one, and the residential and the transport followed by the services. And this slide gives where to concentrate on the energy audit first. The industrials from 1973 to now, it's almost tenfold it is increased, followed by the transport and residential sector. And this is another important slide. From 2001, our consumption of Indian consumption increased by 55% from last decade, especially the oil and coal. And this is a common incentive of the India. If you see the power production, because most of the thing is coming from the coal-based power plant, therefore we are quite high in the first graph. You can see it. We are almost around 1, 2, 3, 4, 5, 6, 8th player. And per capita consumption, we are the low because of our population, and still our energy requirement is. We may be the third largest generation in the world, but still our population also we are number 2. Therefore, per capita consumption of the CO2 we are less. That is the only argument we always do in the international form to escape from the penalties. And this is a projection given by Niti Aayog and other government bodies. They want to reduce the coal consumption and increase the solar. This is the solar, the orange color, which is increasing the solar. We are going to increase it. And when you're coming to the energy audit and other scenario, and we have to reduce the maximum the carbon dioxide and greenhouse gas emission. And this is a study which was carried out. You can compensate the renewable till some extent, and still our conventional flows will be there. Therefore, the energy efficiency can contribute around 50% to the reduction. And the rest is a biofuel is 1%, nuclear if you increase also 8%, and carbon storage method still is in the initial stages. Even the hydrogen fuels, they can contribute later by 8%. And as earlier slides indicated, our consumption is increasing. The primary demand was around 421 million tons per oil equivalent, because most of the time we refer in the energy is a million tons per oil equivalent only, because there are different kinds of fuels like coal, biomass, everything. Everything, the calorific value, they convert into oil equivalent to have a common factor. And by this year, I'm not taking into account that last year we are around 850 million tons oil equivalent in 2019. And same thing we're expecting by 2030, around by 2 different agencies estimated around 1,250 million ton oil equivalent, and by another agency we are estimating around 1,500 million oil equivalent energy consumption, which will be almost double. Therefore, the importance of the energy efficiency, it is dual objective. It promotes substantial development and economic competitive. And in addition to it improves in the health, environment. As you know, the carbon dioxide emission, CO2 emissions, already we are seeing the bigger cities in the North India, the Delhi, every winter, there's no wind movement. There's always restrictions. Next, as Dr. Vinayak referred, this important body which was established in 2001, that is called Bureau of Energy Efficiency. It comes under the Ministry of Power, which is a nodal agency. And the state-wise, there's another state designated agencies, which is in Karnataka is the CREDL, which looks after the standard and labeling, energy consumption codes for the buildings, and the PAT scheme, that is for the designated consumers, and a certification and application for the energy auditors and managers, and best practices, capacity building, and partnerships with other countries. The low carbon economic and the society, if you see, we have to reduce the carbon dioxide emission. Already we are in 550 ppm at present, which will give rise to the 3 to 6 meters of the sea level by 2000, which we are seeing the effects already in the present scenario. We no need to wait for another 80 years to see that effects. Therefore, we are mitigating to the non-fossil fuels, and improving the energy consumption by efficiency, so that GDP also improves and economic growth also improves for the country. We are not only concentrating for the country, we are looking at the world as a one. Therefore, the main thing is the energy management is nothing but a strategy to optimize the energy, both in the procurement and utilization. For example, in India, we have a large quantity of coal, which can even last another 60 years. Still, we import a coal from Australia, South Africa, and Indonesia. That is an energy management strategy. Like most of the ultra megawatt power plants, which are in the sea coast, like in Gujarat, Krishnapatnam, or any like in Tuticorin, which can import the coal at present to meet the energy. But statistically, the government is decided to store the coal for the future. That is one type of energy management, both in the procurement and utilization, and systems and the procedures. It will be reduction in the specific consumption to minimize the energy cost. Like now, there's now the latest power plants doesn't have the power purchase agreement. Everything is sold to the energy exchange. Therefore, everybody can bid at hourly basis or per day basis their requirement. There is energy cost saving. And next is energy costs are always fluctuating, as you must be familiar now. Most of them have the vehicles. Therefore, every day you see in the petrol bank, there will be always a change. Similarly, the cost of every day the fuel keeps changing. Therefore, that is the energy management plays important this one. Like our minister told, the petroleum minister, when there was energy cost was very low due to the pandemic, they filled our almost the reservoirs of the crude oil to take the benefit of the low cost, which he brought it around I think $25 per barrel. Now it's coming around $40 per barrel. That is all the energy management strategies. It can save the money, and you can use for the other requirements. Now we are using it for our medical and other benefits in our country. And another type of energy management is also called as a demand side management, which is energy management is a broad based. Demand side management is nothing but you'll be all familiar, the load shedding, and wherever the agriculture sector is given in the off, not in the peak periods. That's all the demand side management, they do it. And energy management strategy always is a conservation, as I referred the earlier situation, to not to waste the energy, or to save our fuel and get the fuel from other country, to make it as a national strategy for the reserves. And next is the efficiency is a reduction. by using more efficient equipments like the motors. Now, if you see, there's a IE5, IE4 motors available, whereas earlier motors were efficiency of 88 or 85%. Now the motors, same motors are available with 92%. There's an increase of 5 to 6% efficiency. And as the energy management, the energy efficiency is a part of the energy management. It cuts down the operational cost and increases the competitiveness. And energy is a controllable cost. Possibly exists to make a significant reduction in the energy bills. This can even, you can look at your home, like in a simple home. We did a study in the residential sector also. We found that the TVs, normally it's now the TVs are controlled by remote. Normally we switch off the TV by the remote, but normally if you see the TV is still on the active mode, it consumes around 2 watts continuously. Therefore, when the night time, when you are switching off the remote, you even switch off the incoming supply to the TV. There's a top-up box and everything. They consume more still. That are the small things. If you do it in the house, the overall the consumption of energy accounts to the nation will be huge. Energy audit is multidisciplinary, as initially when I started my talk I gave. It always the team will be consist of different disciplines, like from a mechanical, chemical, electrical. It's always an approach of a multidisciplinary, because when you go to industry, it's totally different, because every even the civil also plays a key role. All the engineering discipline makes we combinedly study so that to get a better savings in that. Energy, after doing energy audit, we quantify how much is the energy usage at each division or each section. Next, we use effective tools, measurement tools to identify the losses and give a presentation to them, where all the reduction and what will be the investment cost. Most of the things we see, there's a without investment, a process modification or a practices gives them the saving of 5 to 6% immediately in the industry. As need of audit, in need of industry or any place is the energy, labor, and the material. Therefore, energy plays an important role. If you go to a steel plant, its energy constitutes almost 50 to 60% of a cost of the production. And similarly, if you go to a cement plant, it will be around 40%, because lime is they are already the mines. Next is always they have to use a coal, which is always they have to buy it from others. That is nothing but energy. Next is the labor and the material. Material is anyhow in the cement is a lime. Therefore, the cost of the energy is very high. Therefore, the audit gives scope for a reduction in the energy cost, which benefits to the plant and benefits to the environment, because we are less emission due to the less use of the carbon fuels. And we try to suggest a different variation in the different fuels so that the energy cost can come down, identify the energy conservation technology and retrofits. And the primary object is to reduce the specific energy of the any product. And it helps us in the benchmarking. We compare with the international benchmarks. Sometimes in India, some sectors we do as better than the world benchmark. Like in case of the cement sector, we are doing very good. In case of the steel, we are doing very badly. Power sector, we are still improving. And it provides a planning for more effective use of the energy also. And types of the audit depends upon the type of the industry, function, how depth audit has to be carried out, and potential and magnitude cost and reduction. Primary audit we do for a big industry, first to establish the energy consumption, estimate the scope of saving, and estimate the low cost and no cost savings, identify in-depth study areas, and detailed audit we carry out, because sometimes if you go to a steel industry, it's a very huge, massive plant. If you are doing the total audit for a plant, it might even take a 6 months duration. Before we try to concentrate, we discuss with the client, the industry, and try to concentrate on where is a major savings, so that they can also implement, and the study period also can be reduced to a month or two. And we have large instruments around worth of around 10 crores with us, which we carry depending upon the industry to study the plant. And we have to do energy balance for any system, even a boiler or a kiln in a cement plant or a furnace, to estimate the efficiency, where are the energy losses, and look at their operating practices. And it's actually, energy audit will be a challenging. If anybody interested in the, especially the students wanting a challenging life, the energy audit is a challenging life. Every day you have to keep on studying. Like we are going to the next day to a plant, because you are challenging a person who's 24/7 in the plant, and you are visiting only for a 1 month or a 2 weeks. You do an audit, you are challenging with them. This is a practice you have to change. Therefore, you have to be more thorough, and you have to give the examples of the previous auditors. Therefore, it's like a doctor, no? The energy audit also will be keeping adding up your experience every day, and you study something the new in that plant also, which you can carry out to the other plant. But don't mistake this audit word, no, with like a general accounts audit. Under accounts audit, a single person can do it, whereas a detailed or the energy audit has to be carried with a multidisciplinary. These are the steps normally we do it in energy audit. Data collection. Like example, for a university, you can first data collect, first analyze the BESCOM bills or your own diesel consumption from your diesel generation stations, and observe. And next, observations: when is the peak period, when is the low peak period, or what is happening on the Saturdays and Sundays when the college is closed or on the vacation. And measurement and trials. Sometimes some places there'll be no metering, therefore you have to do a measurement, like in a major data center or the UPS, and data analysis and finding, and implementing some measures. Like sometimes the security lights, which is normally operated by a security person, they may not even switch off. They can look at option how to trial putting auto sensors or a timer. You can take that similar trials and look for the economic evaluation. If you are retrofitting the like a sodium bulbs with the LEDs, what is the costing, and detailed prepared report can be prepared and present to the management, so that action plan be prepared and implemented. The benefits of energy audit: it's basically reduction is the energy bills. Every company will love to see the energy bills coming down, and increases the competitiveness, increases the productivity, improves the quality, and increases the profit. At last, the management looks at the profit only, most of the managements. And for the nation, it reduces the energy imports, because our oil import is almost contributes to 80%. Our 20% is only indigenous oil available, and avoids a cost can be used for the poverty evaluation or our health improvement facilities, hospitals, and energy conservation, limited resources, and improves our security, energy security. And globally, it's nothing like energy is nothing. You can take it. You can't isolate Pakistan or India or this one. Therefore, we have to do it globally. Then only the monsoon keeps changing. The monsoon is the moisture comes from the Pacific Ocean. Therefore, it's greenhouse gas affects globally, not India or a nation or anything. Therefore, energy efficiency, the total benefit to our mankind. And the technical factors like age of the plant and machineries. For example, If you're looking at our Raichur power plant, which was established in 1975, 74, still we are running it. Actually, the technical life is around 25 to 30 years. Still, after 40 years also, we are running the plant. That is a technical factor which management can take a decision to shut down rather than the energy efficiency. They can put a supercritical power plant. That is, I think the government is coming with that norms, the switching of the old power plants. Or the newer power plants also, sometimes the optimization has to be done. There'll be some equipments which will be oversized, or design will be oversized. Then we try to optimize in the power plants or in any industry. And quantity of energy used, like the good coals, because our Indian coal is high fly ash. How to combine with the imported coal and use it. And economic factor, plant utilization factor. Like if you see now the present pandemic, our PLF of the power plants are only 45%. How to improve it? With the low PLF, how to make the energy efficiency in the plant? Because some equipments will be working in inefficient mode. Even the boiler also will be in inefficient mode. How to optimize the burners? How to optimize the air coal ratio? And in different power plant, leaving the power plants, the production volumes, like now the volumes will be less. They can do it production in a one shift rather than spread out with the 3 shifts. Then work practice, layout, housekeeping also affects sometimes. And labor skills. This all labor skills and experience of own all comes in the small sectors like SMEs. Next is the energy conservation approach. How your organization adapts to the energy management. Where they look for the savings, action plan, prepare the implementation process. How to make the program and continuous and ongoing activity. It's not a one-time activity. It's every day you're going to consume the energy. Therefore, it's an ongoing activity. 365, and as Dr. Vinayak told, it's till the end of the mankind. First, we have to establish a baseline of any section or anything. Then we can optimize the design so that we can reduce the energy consumption. Then we can, the management also will show the interest. From A level to we come to B level. That is more important. You have to quantify the energies consumption at the present level, and next you have to, after the audit, when you do the implementation, you have to recheck it. Then only it will be make the energy audit more attractive. And estimation losses of energy in the mass balance with the losses, to show them the losses, so that if it is a big budget, then they can implement it. Estimation of efficiencies and performance, so that we can look for a retrofit with the latest equipment which is having higher efficiencies. Identifying the contribution to deviation in the specific energy losses, and looking at the loss reduction in electrical systems, loss recovery, like retrofits, like waste heat recoveries in case of where the heat energy is used. These are the example I just included in the slides for the motors. If you see where it should be suitable to replace. If it is high efficient motor like IE2 or IE3, no need to replace now. If it is a standard motor, then you can replace it. Then you can regain almost around 6% of efficiency. And if sometimes due to design, they must have designed a bigger motor, then it's better if looking at the present operation, you can downsize the motor, because the efficiency of the motor curve is almost flat after 50% of loading till 110%. Below that, the efficiency of the motor is very low. It's around 40 to 50% only. And depending upon operating hours, you can take a call. If low operating hours, it's only a periodic operation, then you can leave it out. If it is continuous in the industry at 24/7, you can take immediate call. Next is our Indian practice. When the motor fails, we send it for the rewinding and rewind it and use it. But each time rewinding, he loses around 2 to 3% of the efficiency, because factory finish is always compact, and the amount of copper wire used inside the motor is compact and it's huge. The EMF generated is also well. Whereas when we rewind it, it's all done by a manual method. The amount of copper wire rewinded inside is less. Therefore, the air and it's not so compact. Therefore, every time you lose 3%. And each time he tries to rewind, he eats and remove the core and inside the core. Each time it will lose 3-4%. Therefore, it's a continuous 24/7 operation. You're losing 5% is huge loss. And this is for the, if you are going to an industry, it's always the main, another consumption will be the air compressors. Depending upon the stage, on pressure, the requirement, how to retrofit it. But sometimes the consumption must have come down or leakages will be there. You have to take a call, how to optimize the speed. And if it is a different pressure zones, you can isolate it to a smaller compressors for a small usage, high pressure one, rather than you putting a high pressure compressor for the total usage by reducing with the pressure sensors. And fans are maximum. If you're looking at the fans, it will major big fans like 2 megawatt or 3 megawatt fans, or will be in the cement mills and the mines. Therefore, we have to look at the fan. What is the fan efficiency? Cutting down or trimming the impeller, replacing with a smaller fan, or putting a VFT or a fluidized coupling. And pumps is a daily need of any industry or anything. Therefore, there'll be always, my experience, I've seen the pumps always is design is always they design it differently, and the working operation is in the totally different zone. Therefore, the efficiency of the pumping is very bad in most of the industries. Then the pump will be always around 75 to 80% is the maximum efficiency, and the operation will be always 50 or 60. Therefore, we had to see why they bought a high pressure pump when the requirement was low pressure, and maybe the requirement of the liquid or the water will not be so high, but still they use high pumps and throttle it. This gives a clear indication. Like the fuel, if you're giving out for 100 units equivalent fuel, the power plant efficiency is only 70%. At present, any of the supercritical power plants are coming up, which comes around a bit more efficient. That is around, you can get it around 65 to 64%, and transmission loss around 11%. And you can see motor efficiency 90%. If you take it, is around 10% loss, and pump is around 75%. Next is the piping loss, friction loss, and next comes the user throttling it. And finally, if you see the end use of the energy is only 9.5% units. Therefore, from the generation to the end user, if the end user saves 1 unit, it's almost equivalent to saving a 2 unit at the generation point, excluding the power plant loss. Any questions, sir?
So what we can do, we'll keep the question and answer session after the end of your presentation.
Okay. Okay.
An exclusive session on that.
Okay.
Meanwhile, if anybody interested, you can ask through chat box. We'll go through the question and answer sessions.
Okay, sir. This one I included because this is very important as our younger generation will be looking at, because we are committed to the world in 2008. That is India commitment to the world that we'll be reducing our emission of GDP by 33 to 35% by 2030 from 2005 level. This is a very important commitment. We are committed to the world. Therefore, everybody is looking at it, how we are going to reduce it. And the government of India kept around 8 missions for achieving this. These are the missions. We kept a national solar mission. As you know, by 2022, we want to achieve around 175 gigahertz. Next is enhance energy efficiency, which I'll be discussing in the subsequent slides, and substantial habitat, that is housing sectors, water mission, and we are addressing the Himalaya ecosystem, and green India, and substantial the agriculture, that is organic food and other things, and strategic knowledge for the climate change. These are the 8 missions the government of India has committed to the world. And by energy efficiency itself, we are looking at opportunity of 74,000 crores. Under the energy efficiency, there's a 4 major divisions. Okay, one is for the energy intensive industries, target for the mandatory energy saving. This is the government of India will be giving a target. This is called a PAT. PAT is nothing but perform, achieve, and trade. Any industry, or I think later the university is also coming into that. You have to perform, achieve the savings, and later the certificates will be certified by an auditor or anybody, which you can trade. It will be a monetary, you can gain it from the your savings. Next is the ESCO projects, which government encourages to replace the old equipment with the new equipment, with the supply installing, and without any investment, you'll be taking back from the savings the amount. Next is government is running a program for replacing the motors for the SMEs and the small scale sectors, which government will procure in a huge quantity and replace, which improves from the standard motor to the energy efficient motor. Next, energy efficient appliances. I think you'll be seeing day-to-day life. The BESCOM has replaced lights with the LED lamps, and other DSM activities they're doing. These are the most familiar stickers you must have seen in your appliances in the home, for the AC, air conditioners, or fridges, or even the fans. Now the ceiling fans also is available, and motors, even the transformers, the small kVA transformers also coming with the stickers. The higher the star, higher the efficiency. While buying, I think sometimes you have to take sometimes you see the cost of the 2-star will be very less compared to the 4-star. If you look at the operation of 2-3 years, then you will be looking at the energy cost. See, the 680 per year to 4-star is consuming on 465, and energy cost is around at present, I think 6 to 7 rupees. If you calculate it at the where you're going to buy the equipment, you'll say you'll better to buy the 4-star equipment. So. And I kept these slides of PAT scheme because the PAT scheme is going to be coming enforced to all your colleges and not colleges, the university. Therefore, I want to concentrate more on the PAT scheme. They'll be doing a benchmarking of your present consumption of last 3 years, and looking at the benchmark of the world, and they'll this slide will give the better information. Like initially, the auditor will come and establish a baseline. Next, the SEC reduction target will be given by the government. You have to achieve this target within the 3 years, and once again after the 3 years, they'll come and monitoring and verification will be done. How much is your target achieved? And above that, the E certificates will be given. E certificates can be like you can sell it in the market, which has to be bought by the industry or the university, which they never achieved. They have to fulfill that one by the buying the E certificates. These are the market cycle is completed. The energy efficiency. This one is introduced in India only first time. This scheme is observed from all over the world. They also want, other countries also want to adapt this scheme. It's because it's a market-oriented scheme. This scheme was started in 2007-10. Was the first PAT cycle, and first PAT cycle it was completed with 478 industries. In the major industries was only 8 sectors: the cement, steel, textiles, chloroalkalic, which are the heavy industries. They only concentrate on that. And the next cycle, it was included even the railways, refineries, and the hotels, the major 5-star hotels. Now, the present cycle, we are looking at present cycle of 2021. They included 3 more sectors. Initially, it was 8. Next, it was 11 sectors. Now we are adding up more 3 sectors. That is, we are adding up. We are coming to 14 sectors. No, 4 sectors more. That is 15 sectors. The 15 sectors is nothing but airports will be added up into that sector, followed by the universities, hospitals, the major hospitals. Next is the data centers. As you know, IT sector, the data centers are huge NEC guzzles. And this is how the PAT scheme works. The trading sector will be issuing the certificates who achieve that. If the company who has not achieved, they have to buy the e-certificates. And it's a mandatory. There's no question of non-compliance here. If you non-compliance, the ministry has the power to close the organization, or the penalty will be imposed more. It's a mandatory one. And this was the achievement of the first PAT cycle. They achieved around 8.6 on metric ton of oil equivalent. Around carbon dioxide mitigation was around 31 million tons of oil equivalent. Million tons carbon dioxide was reduction was there. And about TERI, we are around 1,000 professionals working at different locations. Main is a head office is in Delhi, Bangalore, Goa, Mureshwar, Guwahati, and Bombay. And we have international offices in Africa, Japan, Malaysia. And we work with the major world organizations like World Bank, UNDP, Asian Development Bank. These are the, we not only preach, we also implement ourselves. This is our retreat building in Gurgaon, which has the energy efficient architecture, low level system, earth coupled cooling system. It's a very good green building. Passive cooling, and 100%, 40% energy saving cost, 100% water is recycled and reused within the building, and the solar integration is also done. Natural sunlight integration also is done. And this is the building of the Bangalore office, which you can visit after the pandemic. Any of the students are interested from the civil and the architect. It's an interesting building. There's a big drainage behind our building. Therefore, we have a solar wall, which acts like a semi, and it takes out, it makes a natural convection of air to flow from the north side to the south. We don't get any odor smell from the drainage. And this is our university building in Delhi. It's also an energy efficient green building. And this knowledge we replicated and shared to many other clients, to IIT Kanpur and many other clients. We have shared it. And GREA was developed by TERI, which is now taken over by the Ministry of Renewable Energy. And the more GREA is implemented in all the government buildings. At present, any central government buildings follow the GREA principle only. And slowly the state government buildings are following, and I think later they'll make it mandatory for the even the residential sectors in future. GREA will reimburse the money if you are doing more efficient building, using the 5-star. These are the capital intensive incentives they'll be given by the government of India. These are the few GRA implemented projects. You can see how they integrated with the naturally, the tree and other projects without disturbing any tree or anything. With a natural integration, the building was constructed. Yes, sir, I can take the questions.
Thank you, sir. Thank you for your wonderful talk. Now I request the audience to raise your questions to sir. He is a very resourceful person in the field of energy and energy audit, especially students. Please feel free to ask the questions. Yeah. Hello. I think.
I think once we can give a training for the how to do the audit in your college, sir, after the pandemic.
Yeah, definitely, sir. It is our pleasure. Actually, we are planning for that. We are planning for that, and we will consult you for that.
Yes, sir. I will train the students only. Let them do the study.
Yes, sir. Yes, sir. So there is one question from Vehal. Sir,
Yes.
what is your thoughts on destroying Earth and going to Mars as a backup? Sorry.
The going to Mars is too long.
Yeah.
Now we are suffering already for what we have done.
Yeah.
Actually, our forefathers kept our Earth very well by using biomass and other things. Now we, on the name of the development, already we spoiled it.
Correct.
If we, for your information, if you go to any ancient temples or anything, or any ancient buildings,
yes,
it will be very cool.
Yes, definitely.
Not much AC or anything. It's a natural cooling. If you see, they have a natural pond or a direction of the orientation, natural flow of air will be there. But nowadays, if you see any IT building or anything, it's only a glass, the pillars and the glass.
Yeah.
Actually,
that covers the natural ventilation also, as well natural light also.
Yes, we are destroying it. Yeah. Therefore, it's still not, time is not up. We can save now. Actually, this year we are done, due to the COVID, we are done better, I think.
People are saying that from far distance, Himalayan mountains can be seen. It is because
yes, sir. Actually, if you see, our Bangalore environment itself is improved a lot.
Yes.
Compared to the last year.
In one word, Earth has balanced itself. And but, one question from Supriya.
It's not a way balance we must done. We must not done. We must have done it more better way.
Correct, sir. Yeah, you're right. Yeah,
therefore, you know, all the countries in the world have signed the Paris Agreement. They committed to become a carbon neutral by they're given the self goal targets. Okay, that is the Indian target is given by 2030. Yes. We'll reduce by 30 to 35%.
30 to 30. Actually, what is that? Kyoto Protocol was telling like by 2020 half of the carbon emissions. Like there was the earlier agreement.
Earlier agreement, because due to in that time most of the countries were not signatory for the Kyoto Agreement. Therefore, it was replaced with this Paris Agreement.
Recently, Prime Minister Modi has signed this.
Yes, sir.
We call that. And one more question from Supriya Chaudhary. Good afternoon, everyone. I wanted to know how to cure Earth from toxicity by one single method or way. She is asking very broad question, and she wants.
Not a single way. Every person has to think in a green way. Like they have to go. Like if she has a small house, let her go grow a vegetable in a garden. That is one way of small contribution. Or planting a tree in front of her house. That is a contribution. Yes. Every person plants a tree, no, it will come back. Our Earth can come back to the original way. And earlier, most of them are using the cycles. Now we use vehicles. Now we can shift it to the electrical vehicles, which is emission is almost zero. We can think in that mode. Everybody has to contribute here. Not
Yeah, yeah.
One person has to contribute, one person has to enjoy.
Yes, yes. And I have one question, sir.
Contribution in the society.
Yes.
Like what our suggestion is, like we even did a study for the BBMP. We want the compost of the green wet waste in the ward itself. Now what we are doing, we are shifting this wet waste to the almost to Mandur or somewhere and dumping it. The
Yes.
wet waste is the almost a compost which can be used in that in the ward itself, from the parks or many things. It's all many the society totally we have to work towards that, sir.
Yes.
Like we have to start using metros instead of the private vehicles.
All right, sir. Sir, I have one question. Can you please tell us, means what is the penetration of renewable energy like biomass, wind, and solar in the coming 10 years, like, and what extent we can replace fossil coal-based power generation methods in the coming 10 years, because it would be very crucial as far as India is concerned, because 2030 we have to reduce one third, you are telling, of the carbon emissions what at present. So how penetration of renewable energy resources help in this regard, and what extent we could achieve this?
We at present, as we see, sir, from last 5 years, our renewable is picked up a lot, especially the solar and the wind. We increased the generation, and I think one day in May, I think Karnataka achieved almost 88% of the day running in the renewable energy. That is one of the achievement we did in this year. Whereas as a government, they after our 75 years of independence, they kept a target of 175 gigahertz. Maybe we will not meet that target due to reasons of a pandemic, and our economic activities also come down. Maybe we will be touching 100 giga. That itself is a very good. And later they want to, another project the government of India is doing is the Kusum project, which they want this agriculture pumps, which they use the electricity, which governments, most of the state governments give a free subsidy. They want to put a solar pumps and generate the power and inject to the grid when they are not pumping it. That way they want to add more solar panels. And wind is limited to the selected locations, whereas the sun solar generation is everywhere, even the rooftops. Rooftops also. The BESCOM, if you visit the BESCOM website, they give you a subsidy, sir, to put it on the house rooftops also, solar, which will be beneficial. Actually, the cost of the solar from last 10 years back, which was reduced to almost a quarter now, if we take it in the costing.
Yes.
And actually, we are going aggressively, but 100% we can't replace the
fossil based
conventional energy, because all this renewable energy, the wind is, as you know, it's only during the monsoon period, only the wind is more. And solar, as you know, it's during the morning, from morning 7 to evening 4 or 4:30 max. Next is they're looking for the storage method to store the energy by pumping the water, and peak hours they want to drain the water from Sharavati to the below dam and repump the water and store it in the daytime. That is the way they are looking. But due to the environment concerns, no, it's all slow going projects. They want a battery storage, and batteries, as you know, chemical engineers will be knowing it. The conversion efficiency is very poor. They're coming up with new technologies. This renewable energy is not 100% replacement to presently the conventional energy. They're looking most promising fuel is hydrogen, but hydrogen where to put a lot of investment for the generation of hydrogen. That is one of the green fuels. And any nuclear, the concerns.
Correct.
Most of them don't want next to their backyard the nuclear power plant. That is the concern. Therefore, the conventional fuel, as one of the slides showed, still it will be existing. The government, whatever does also, we are expecting the conventional fuel to be there another So 40 years, sir.
Yes.
It's very difficult.
To replace.
But we are looking at supercritical power plants, which is more efficient, sir.
Correct. Yeah.
Now the government is phased out, trying to phase out all this 210.
Correct. Subcritical plants are phased out.
Yes, sir. And now I think there was a notification last month also. Whichever the power plant, the heat rate, it's more than 2,600 kilocalories per kWh to be phased out.
Achha.
That we, because the government of India has kept another, I think students are very interesting asking the pollution control. For the NOx and the SOx, they kept all the power plants will be implemented by 2022, the scrubber, gas conditioning, FGDs at the chimney. Yes. Therefore, there will be no emission, almost nil.
SOx and NOx.
Yes, sir. Therefore, most of the older power plants doesn't have the place, and they can't be implemented because it's they can't achieve that. Therefore, they'll be phased out.
Correct.
Therefore, they are coming with the supercritical power plants with 800 or 600, which is beneficiaries. You know, the supercritical power plant heat rate is around in Kudili, that NTPC power plant is in. It is 1,860 kilocalorie per kWh. Whereas if you visit any other power plant, it will be 2,600. What is the difference? Is around 800 kilocalories we are losing.
Correct. Yeah, that is because of this latent heat absorption.
Yes,
that is not there. Phase change is not present there, and obviously the fuel burnt is less.
Yes, sir.
Great, sir. Great. Very nice. And students should know what is supercritical operation of the plant, and why it is helpful, and why government has made it mandatory to go for supercritical plants. So these are all very important aspects, because we are using the energy every part of our life, every second of our life. Without for a single minute, we cannot see watching our mobile, and that energy intense the life has become. So it's a very good talk, sir, and very informative to our students. Thanks for this. And now I request Professor Mrityunjay Swami to extend the vote of thanks. If there are no questions, 1 minute, sir. Let me. There is one more question. How long will we take to switch off from coal as a major source of energy to solar and wind? Same, sir has answered it in a just now.
And for the student, I am telling the coal is only our reserve.
Yes.
Which can last even 100 years. Okay. The other fuels, if you are thinking like oil, we are already importing 80%, and our foreign exchange will come down. Therefore, that's why the government is looking for the nuclear as a clean fuel, and hydro, due to the environment restrictions and many things. Hydro also is not at 365 days generation. It's also in the monsoon period, because our importance is for the agriculture, the water storage, not for the hydro generation. There are some limitations. I think the solar PV only will increase it, but coal, it can't be ruled out.
Solar thermal, I think it has taken a back foot. What I feel, solar thermal.
Solar thermal also, sir, it's only picked up in Rajasthan, where the temperatures are quite high in the summer.
Thank you, sir. Thanks a lot. You are very resourceful person in this regard, related to energy sector. We are very grateful to have you here. Now I request Professor Mrityunjay Swami to extend the vote of thanks.
Good afternoon, one and all. We are fortunate to have such a wonderful talk on green energy and energy audit by Shri Ramesh Dharmaraj sir from Theri. Sir started this discussion with the effects on environment using the conventional energy resources like solid, liquid, as well as gaseous fuels such as coal, gas, liquid fuels, and which results in serious solid, liquid, as well as air pollution. He also highlighted the green energy resources like the solar energy, wind energy, hydro energy, and effective utilization of energy in building, transport, as well as community networks. And also he explained beautifully, the energy audit is the complete inspection of building from top to bottom by proven technologies and specialized testing equipments for effective utilization of energy resources. It may be heat energy or electrical energy, minimizing the energy losses in various stages of utilization and reducing the cost of the energy. We have also highlighted the energy conservation and also energy efficiency to reduce the cost of the electricity bills. And also he highlighted the types of the audits like energy audits like preliminary audit, detailed audit. He also highlighted the steps involved in energy audit like data collection, observations, data analysis and findings, implementation of measures, techno-economical evaluation, detailed report, action plan, and also implementation of the energy audit. We also highlighted the energy efficiency benefits for industries, national level and also global level. On behalf of Dayanand Sagar University, I extend my heartfelt thanks to Sri Ramesh Dharmaraj sir for accepting our invitation in spite of his busy schedule and exchanging meaningful views on green energy and energy audit. Thank you very much, sir. Thank you very much, sir. I also extend my sincere thanks to Vice Chancellor sir, Registrar sir, Deans of all the schools, Chairmen of various departments, Professor Vinayak Hemadri sir for IQAC coordinator, and faculty and students for active participation in this webinar discussions. Thank you one and all. Have a nice time.
Thank you, Ramesh sir. Very nice to meet you, and I'll be in touch with you, sir. I'll be in touch.
Thank you, sir. Thank you, sir.
Okay. Thanks a lot, sir, for your time and your valuable presentation.
Thank you.
Thank you, sir. Yeah, thanks. Yeah, I take your leave. So,